Rising carbon dioxide levels are not necessarily good for agriculture. The benefits of CO2 for plants may be less than previously thought, and potentially counteracted by the damaging effects of the proliferation of surface ozone. Agriculture has always faced the challenge of weather variability. Altered agricultural conditions under a transforming climate could exceed farmers' ability to adapt. Farming could easily become adversely affected by extreme heat and escalating water demands, inflated frequency of severe weather events such as drought and flood, sea level rise and flooding of coastal plains, and modification in crop nutrient content. Variability is also likely to occur in the number and type of pathogens and pests affecting plants and livestock. Altered use of pesticides, damage to fisheries and aquaculture, and mycotoxin contamination. There are numerous fine-scale processes that can moderate vegetation responses to nitrogen deposits. While a smaller amount of nitrogen may act as fertilizer, stimulating growth in plants, large accumulated amounts can decrease soil health and cause a loss in the number of plant species. These vital food security issues need to be dealt with and modeled into future plans for livestock expansion. The reality is animal-based diets will become even less efficient and further wasteful as planetary heating intensifies. The Food and Agricultural Organization's assessments do not fully factor in the effects of climate warming on plants and crops. In particular, as the land warms, droughts may reduce tree productivity and survival across many forest ecosystems. If the vapor pressure deficit continues to climb, forest drought stress by the 2050s will exceed that of the most severe droughts in the last 1,000 years. Upwards of 60% of crop variability can be attributed to climate irregularity, and unnervingly, this variation occurs in regions that are principal producers of major crops like the Midwestern US, the Northern China Plains, Western Europe, and Japan. Direct climate impacts to maize, soybean, wheat, rice under an adverse RCP 8.2 scenario could involve average losses of 400 to 2,600 calories, or 8 to 43% of the present-day total. Freshwater limitations in some heavily irrigated regions could necessitate reversion of 20 to 60 million hectares of cropland from irrigated to rain-fed management. These projections are a major cause for concern. Many subtropical, arid, and semi-arid regions will probably experience less precipitation. In wet tropical regions, extreme precipitation events will be further intense and frequent. Monsoon onset dates will start earlier, while withdrawal rates are going to be delayed, resulting in a lengthening of the season. Tropical cyclones are expected to become extra intense with stronger winds and heavier rainfall. In addition, variability of climate such as El Niño events has large impacts on crop production. Africa will be the part of the world that is most vulnerable to climate variability and alteration. East Africa will experience further short rains, while West Africa will get heavier monsoons. Much higher temperatures could reduce the length of the growing period in some parts of Africa by up to 20%.